Imagine a battlefield where the speed of light becomes the ultimate weapon. No loud explosion, no visible missile trail across the sky. Just a silent, invisible beam that travels at 300,000 kilometers per second and disables its target almost instantly. This is the reality of directed energy weapons, commonly known as laser weapons, and they are rapidly transforming the future of modern warfare. Directed energy weapons, or DEWs, use focused energy, such as high-energy lasers, to damage, disable, or destroy enemy equipment. Unlike traditional weapons that rely on bullets, explosives, or kinetic impact, laser weapons deliver energy directly to a target. The result is precision at the speed of light. Once the operator pulls the trigger, there is virtually no delay between engagement and impact. At the heart of laser weapons is a powerful energy source. Electrical energy is generated and stored, then converted into an intense beam of light. This beam is amplified and focused through a series of mirrors and optical systems until it becomes powerful enough to burn through metal, damage sensors, ignite fuel, or disable electronics. When that concentrated energy hits a target, it heats the surface rapidly. Within seconds, or even fractions of a second, the target can be rendered useless. One of the biggest advantages of laser weapons is precision. Traditional missiles can cause significant collateral damage due to blast radius and fragmentation. Laser systems, on the other hand, can focus on a specific component of a target, such as a drone's wing, a missile's guidance system, or a small boat's engine, without affecting surrounding areas. This makes them especially valuable in urban environments or in defensive scenarios where minimizing unintended damage is critical. Another key advantage is cost per shot. Firing a missile can cost hundreds of thousands or even millions of dollars. Firing a laser costs only the price of the electricity required to generate the beam. Once the system is installed, the operational cost is significantly lower compared to conventional munitions. This economic advantage becomes crucial when defending against swarms of inexpensive drones, where using costly interceptors would be inefficient. Speed is another game changer. Because lasers travel at the speed of light, they are ideal for countering high-speed threats such as rockets, artillery shells, and even certain types of missiles. There is no need to calculate complex interception trajectories like with traditional missile defense systems. As long as the target is within range and line of sight, the laser can engage almost instantly. Several major military powers are actively developing and deploying laser weapon systems. The United States has been testing high-energy laser systems on naval ships and ground vehicles. The U.S. Navy's laser weapon system, known as LAWS, has demonstrated the ability to disable drones and small boats. The U.S. Army is also integrating laser systems onto armored vehicles to counter unmanned aerial systems. Meanwhile, other nations such as China, Russia, and Israel are investing heavily in similar technologies, recognizing the strategic advantage they offer. Naval platforms are particularly suitable for laser weapons. Ships have large power generation capabilities, which are necessary to support high-energy systems. On a warship, a laser can serve as a defensive shield against drones, small boats, and potentially incoming missiles. The ability to fire multiple shots without reloading gives naval forces a continuous defensive capability that traditional weapons cannot match. Ground-based systems are also becoming more common. Mounted on tactical vehicles, these lasers provide mobile air defense against drones and loitering munitions. As unmanned aerial threats continue to evolve, laser weapons offer a flexible and scalable response. Instead of firing expensive interceptors at small quadcopters, a laser can neutralize the threat efficiently. Airborne laser concepts have also been explored. Mounting a laser on an aircraft could theoretically allow it to intercept missiles during their boost phase. Although technical challenges such as size, weight, and power requirements have slowed progress, research continues as technology advances. Despite their advantages, laser weapons are not without limitations. One major challenge is atmospheric interference. Dust, smoke, fog, rain, and humidity can scatter or weaken the laser beam, reducing its effectiveness. Weather conditions can significantly impact performance, especially over long distances. Engineers are working to improve beam control and adaptive optics to minimize these effects. Another limitation is power and cooling. High-energy lasers generate enormous heat, and managing that heat is critical for sustained operation. Without effective cooling systems, the weapon could overheat and shut down. Advances in battery technology, compact power generation, and thermal management are helping to overcome these challenges, but they remain important considerations. Range is also a factor. While lasers travel at the speed of light, their effective range is limited by beam dispersion and atmospheric conditions. They are highly effective at short to medium ranges, particularly for point defense. However, for long-range strike missions, traditional missiles still have advantages. There is also the question of countermeasures. Adversaries may develop reflective coatings, rapid spinning projectiles, or hardened materials designed to reduce laser effectiveness. As with any military technology, the development of new weapons leads to the development of new defenses. This ongoing technological competition will shape the evolution of directed energy systems in the years to come. Beyond lasers, directed energy weapons also include other forms such as high-power microwaves. These systems can disable electronic circuits without necessarily causing visible damage. In a modern battlefield dominated by electronics, communication systems, and drones, the ability to silently disable enemy equipment could provide a decisive advantage. The strategic implications of laser weapons are significant. They represent a shift from ammunition-based warfare to energy-based warfare. Logistics may change dramatically. Instead of transporting large quantities of missiles and shells, forces may prioritize fuel and power generation capacity. This shift could influence military planning, base design, and even the structure of future armed forces. Laser weapons also raise important legal and ethical considerations. International agreements regulate certain types of weapons, including blinding laser weapons specifically designed to cause permanent blindness. As directed energy technology advances, policymakers must consider how to regulate its use responsibly while maintaining national security. In the broader context of modern warfare, directed energy weapons are part of a larger technological transformation that includes artificial intelligence, hypersonic systems, and advanced cyber capabilities. Together, these technologies are reshaping how wars are fought and how deterrence is maintained. For military strategists, the appeal of laser weapons lies in their precision, speed, scalability, and cost efficiency. For engineers and scientists, they represent a breakthrough in applied physics and energy management. For defense planners, they offer a new layer of protection against emerging threats like drone swarms and precision-guided munitions. As technology continues to mature, we can expect more powerful, compact, and efficient laser systems. Future battlefields may see layered defenses combining traditional missiles, electronic warfare, and directed energy systems working together seamlessly. In that environment, laser weapons will not replace conventional arms entirely, but they will become a critical component of integrated defense networks. The age of gunpowder and explosives is far from over, but a new era has clearly begun, an era where light itself becomes a weapon. Directed energy systems are no longer science fiction. They are real, operational, and evolving rapidly. The countries that master this technology will gain a powerful strategic advantage in the conflicts of tomorrow. As we look ahead, one thing is certain: the battlefield of the future will be faster, smarter, and more energy-driven than ever before. And at the center of that transformation stands the directed energy weapon, a silent beam of light redefining the rules of modern warfare.